In this video, we are going to talk about Docker from scratch for PHP 8.1 applications in 2022. This video is basically, and let's call it evolution of the one that I did roughly 3 years ago in 2019. So if you didn't watch that one, then I recommend you take a look at that before, because I'm gonna explain some stuff in this previous video in much more detail than I'm gonna do it here. And I put the link in the description of this video. The application that we're going to build is depicted here. So we're basically having like a host machine, and on that host machine we run Docker, and in Docker we run 6 containers, nginx and php-fpm for the front end, then a PHP application container that we use to run CLI commands, and a PHP worker container that runs as a daemon and consumes jobs from a redis queue and puts the result in a mysql database. First of all, we have this very simplistic interface that I can use to control the whole application. And I can now dispatch a job on the queue from the interface. This job should now be visible in the queue. So basically, this is now in the Redis queue, and it should now be consumed by a worker and put in the database. The database is empty for now because there are no workers running. The item is not being picked up. So the next thing I'm going to do is start the workers. So I'm running make start workers, and that will start the workers in the worker container, and they will immediately look at the queue, consume it, so it's now empty, and then put the result in the database. So now I can see this string foo. You might have noticed that I use make commands to control the application. If you haven't been in touch with Make before, then again, I recommend the first video where I talk more about the whole setup and how I use Make to control applications. And building on the explanation of the previous video, I've introduced 3, let's call it new techniques to the Make setup. The first one being includes. So when we take a look at the main Make file, that is pretty slim. So we have some general setup stuff, and then we have this include for other Make files that are located in this .make directory. So we have this directory, and in here we have a couple of other Make files. Again, I use Make for controlling the application, and it can become quite convoluted and big. So I like to split it up into separate subfiles for better organization. In the same folder, you can see this .env file. This file is used only for environment variables that I can also include within Make, and then I can use it for different applications. So I can use it within Make, but I can also use it in a Make recipe, pass it on to different commands. That would basically be the setup. So this is a Make recipe, and in this recipe I can prefix a command with environment variables, and then those variables are available to the command itself. By having this .env file for Make, I have one central place for those variables, and I don't have to define them in multiple different places. And the third thing I want to mention is the error handling. I need input variables for some of the recipes that I defined. Make doesn't really have signatures, but I want to be notified as early as possible if I forgot to specify a certain argument. This is the construct that I would use for that. So I would basically check for a certain variable, and if it is empty, then I would error out immediately. You can see a concrete example on how I would use that for Docker commands, because they need a couple of variables, and I can now basically check for the existence of all of them, and again, error out immediately if they are not defined. As in the previous tutorial, we have again a .docker folder that contains all the Docker relevant stuff. Then we have a Docker Compose folder for all the Docker Compose configuration files, and a folder for all the images. So that's exactly as before. For all the images that are being built as part of the setup, there is a subfolder, and in there I find the corresponding Dockerfile. And the third thing to mention is the .env file for Docker. So that is used to also define variables that are relevant for the Docker setup. Let's start with Docker Compose. The first thing to note here is that we have 3 different Docker Compose files. The usual Docker Compose file that contains all or defines all the services that are used in all environments. An environment being my local development setup, CI/CD, and also production. This file is used in conjunction with the Docker Compose.local file that extends this base file with all services that I need to run locally and also adds the necessary configuration options. So for example, here I do volume sharing of the code base on my host with a container so that any changes are reflected immediately. And you can see that I'm using variables in a couple of different places. And I would always recommend to use the question mark at the end of a variable, because that will make Docker Compose fail immediately if you do not specify this variable. And that has saved me like some debugging time. And apart from that, there are also some variables where I can define like a meaningful default value. So for example, for the nginx port that is proxied through to my local host, I can set this to 80 immediately, and I don't even need to specify that as an input. If that is not the case, then a variable should be either defined in the .env file, or it should be passed through on the command line as environment variable. That's basically what I explained previously with this make setup and the shared variables. Let's now take a look at the concrete service that we are going to build. For example, php-fpm. Since I don't see a build instruction in this local file, I need to take a look at the default Docker Compose YAML file. And in here, we see the build instruction for the image. And there are three things that I want to point out here. First is the name of the image. And I'm a big fan of like a fully qualified image name. I define like the full image with all parts relevant for the image instead of letting Docker Compose choose like the defaults for me. Then we can see the definition of the Dockerfile. That's what I already said. So if this images folder in here, we have a directory, and in the directory we have Dockerfile, and that is true for all the services. And then we have this base image that I use for all the PHP services. And I will talk about that more in a second. But let's start with the image name. Docker image names are split into different parts, and these parts are like the registry in the beginning, then a namespace, and then a service name. In my case, I'm also suffixing the service name with the environment so that I get like unique image strings for each of my environments. Okay, and now I want to take a look at the base image. So let us jump into the Docker file of the php-fpm service. And then instead of using an official php-fpm base image, I'm using an image that I built myself. I've made the experience that this is a lot faster than pulling the base images, especially because building extensions can be quite time consuming, and it's usually much faster to simply install them via apk-add. Then I avoid all duplication across multiple PHP services. The image size will be smaller in the end because we have this like common base image, and then we can leverage layer caching. But it also comes with downsides. We now have like a little bit more complexity when building the containers or when building the images, because we have now like some sort of build dependency. We need to ensure that this base image is built first, and only afterwards we can build the remaining images. But it's also easily solved with GNU Make. Talk about that later. The second problem is that we now depend on the alpine release cycle of PHP. And especially when talking about PHP 8.1, I'm not even sure if that is yet available in the official alpine images. But luckily there is a way around that, because there is a project from Codecasts, and in that project they provide the latest PHP binaries for alpine images. So let's take a look at this Dockerfile for the base image. The very first thing that you will notice is that I have a lot of arguments that I then make available as environment variables. I'm doing that because it's then much easier to reference these variables in the child images. So for example, php-fpm. Next thing, we are going to create a user for the application. And here I would recommend to always create a new user that doesn't yet exist on the system, because it avoids any issues with existing users. Next thing, install some common software in the image. And then we see the Codecast PHP Alpine repository in action. So we basically use that to install the latest version of PHP and also the corresponding extensions. Afterwards, just some general configuration for PHP. Then we use a so-called multi-stage build in Dockerfiles, which means that we can define different so-called build targets or stages in the same Dockerfile. And we use that later to account for differences between different environments. So you will see that all of my images contain this local stage for anything that goes only into the local images. And again, this can be a little bit different for CI/CD and for production. In Docker Compose, this is activated via the target property, and the value again is the environment that we built the image for. So we have MySQL and Redis, which we don't build as own images. Then we have an nginx image that we'll take a look at in a second. We have this PHP base image, and then we have a couple of PHP images that are based on the PHP base image. For MySQL and Redis, again, I'm not building anything, but I'm using the images directly because I can configure them either through environment variables or through like a very simple command. So there's no need to create a custom image. The nginx image uses the official nginx Docker image as a base image, and then we copy a custom configuration. And in that configuration, we make sure that the root points to the public folder in our code base. So basically this folder. And the configuration file itself does exactly that. So we get the correct root. And it defines a way to use php-fpm as a backend. That works because that's the exact service name in my Docker Compose file, and Docker Compose ensures that I can connect from nginx to php-fpm using this name. In the fpm base image, I'm using the common base image. Then I'm installing php-fpm because it's only required for this image. Copying over some configuration files and ensuring that the user that is running php-fpm is the application user that we've created previously in the base image file. Our application PHP image, also using the base image, and then we install OpenSSH. We need that later for PHP Storm so that we can use our Docker setup within PHP Storm. And then finally we have a worker, and that uses supervisor to keep the processes running. So we define a command that is being run that includes our worker, the number of processes to spawn, and also sets the application user as the user running the processes. And also take a look at the configuration file. So the magic happens down here. We define a worker named worker, use the corresponding command, set the user, set the number of processes. And yeah, that's basically it for the worker. Now that we know some of the details of the setup, let's build it from scratch. Stop the current setup, and then we will make sure that we have a clean slate. So I'm running make docker prune, and that will remove all the containers, all the images, all the volumes. So I'm now taking a look at the images. I will see nothing. And from here, I can build them again. And I would do that via make docker build. I'm using the -n flag on make to show the commands without executing the commands. We're running two things here. One is building the base image first, and the second one is then building all the remaining images. Let me start the actual build because that can now take a little time. The first command defines a couple of environment variables, exactly the ones that we saw in the .env file for the make file. It runs Docker Compose, defines a project name, defines environment file, and then defines all the Docker Compose files that are required for the build process. In this case, for the PHP base image, the only file that we want is this docker -compose -php -base file. And the second command essentially looks the same with two differences. We're now using two Docker Compose files. So one is this, like, let's call it default Docker Compose file. And then on top of that, the Docker Compose file with our local settings. Then we don't define a service to build here because that will cause Docker Compose to build all the services that are defined in the whole setup. How does it look in the Makefile? We need to take a look in the Docker sub Makefile, and the target that we executed is this one, this make Docker build target. And it executes two targets. The one is building the base image and the second one is building all the remaining images. When we take a look at building the PHP base image, it looks quite simple. So it uses like a variable that defines all the configuration that we need for Docker Compose to work. Then it runs the build command, and then it defines the service name, in that case php-base, that is supposed to be built. So the magic kind of happens here in this variable. When we take a look at this, then we can see that it's basically built up with two components. One is the Docker Compose command, and the second one is a list, or in this case, really only just one file that contains the Docker Compose files that need to be used for this command. The Docker Compose command is defined up here, contains the list of all the environment variables that are required to be passed to Docker Compose, the project name, and then the environment file. When we combine all of these things together, we get this complex looking string up until the environment file. So all of this is contained in this one variable that we just saw, this Docker Compose command. The build that we started should be finished by now. So let's take a look. That looks good. Make Docker up. Now we're kinda at the beginning of this video again. The first thing that we need to do, and I kind of omitted this in the beginning, is set up the database or set up the table on the database. And I have a make target for that. That is make setup -db, and I can parse arguments to drop any existing tables and recreate them. And when I run this, you see a similar setup as we have just seen before. So all of that stuff should already be familiar to you up until this point. And after that, I'm running exec to execute commands in a container, use a specific user, in that case our application user. I use it on the application container, and then I run PHP on this setup.php script with the -- drop argument. It drops any existing table named jobs and then recreates the tables. How does that look like in the Makefile? It is defined in the application setup Makefile and uses this execute in application container variable to then execute the script. And this variable is defined in my Docker Makefile in this part. What we just saw is defined in this line. So it defines the Docker Compose command. We've already explained that previously, and then uses the exec command with the parameters to run the command that I pass it to. And the interesting part here is that this is only filled if I'm outside of a Docker container. I can check if I'm inside a Docker container when this .dockerenv file exists in the root. If it doesn't exist, then I'm likely outside a Docker container. Why is that important? Because it makes sure that I can run things inside and outside of the container by using the same commands. So let me make that clear. I ran this command outside of the container. I can now log into a container. So I'm now logging into the application container, and then I will run the exact same target. So let me just copy that and run it in here. It was a lot faster. But as you can see, the only thing that was executed was the command itself. So all this, all the prefix stuff here that deals with the correct Docker Compose configuration, all of that is gone. And I'm simply running the script directly in the container. And again, that's great because I can use the same make commands inside or outside of the container. And in the exact same style, I can also define additional commands. So for example, you've seen me stopping and starting workers in the beginning of the video. And yeah, it uses the exact same concept. Only in that case, we're not executing the command in the application container, but instead in the worker container. On to the last part, the PHP files that we use to glue everything together. Let's start with the setup.php file that we use to create the database. First, it includes a file called dependencies, and in that file, I'm simply making sure to configure a redis object and a PDO object for the MySQL connection. And yeah, then I'm evaluating this drop parameter, and if it exists, then I'm going to execute this drop table if exists command. And then I'm recreating or I'm creating the jobs table. The interface, the web interface, which basically consists of the three routes that we've seen. And it also uses the dependencies.php file for getting configured objects to either push a job on the queue, or show the contents of the queue, or show the contents of the database. And finally, we have the worker.php script, also using the dependencies, and it will simply run in an infinite loop. We'll check the queue, or the Redis queue, for any jobs, and if it finds one, then it will be inserted in the database. And in the beginning, I have shown everything by hand, so to speak, but there's also a script that will basically run all of the steps that I have shown manually. Bash test.sh. And that will now build the Docker setup again. That will be quite fast because it already exists and it leverages the caching that I have locally. Once the setup is built, then it will shut down the setup if it's running. Then it's started up again. Then it will make sure that the database exists and is empty. We'll stop all the workers. Then we will see the contents of the queue in the database. They should be empty. Then we will dispatch a job on the queue. Then we will check that something is on the queue because no workers are currently running. Then we start the workers. Then we check the queue again. It should now be empty because the worker has processed the job. And when we check the database, then we should see that basically it is inside, that the job is inside the database. Building is finished. Then we are starting the Docker setup. Then we're making sure that the database is empty. Then we're stopping all the workers. Then we see that the queue is empty and the database is empty. We dispatch the job. It's now on the queue. So we have one item in here. We start the workers, check the queue again. It's now empty. And finally, we check the database and we see, yes, the job was actually processed successfully and is now in the database. To recap, we basically built this setup shown here on this slide. We've also shown that everything is connected in the correct ways, and the whole application is controlled via Make, which is a great way, in my opinion, to manage an application, because all the things that you usually run can be abstracted away in a Make recipe, and you can still look that up, but it's also easily accessible for you and for any other developers that might be working on the project. Thank you for watching.